So, hello everyone. Good afternoon, dear authors and invited guests. Welcome to the technical session 2D. Myself, Saksham Sarraf, and this session will be moderated by me. On the behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you in the International Conference of Communication and Information Technology, ICICT 2023, London, United Kingdom. The eighth version of this conference is organized in a hybrid mode. The physical event was held in London on 20th and 21st February 2023, and the virtual version are going to held through Zoom today and tomorrow, that is 22nd and 23rd February. I hope you will enjoy all the knowledgeable and interactive sessions throughout the day. This session, we have 6 presentations, and each presentation will be given 12 minutes for presentation and 3 minutes for question and answer round. And I'll raise a gentle reminder in 10 minutes. There is another request to all the part presentations that you stick together with us till the closing remarks. And if there any query or any update, just write it to me in the chat box. Now, just before we get started, I would like to introduce you to our session chairs.
Hello, everyone. Good afternoon. Good afternoon from the Netherlands. I am Dr. Deepti Kapoor Sarma, and from University of Twente. And I'm so honored and pleased to be part of this conference virtual session. As Saksham has already elaborated all the points, one more point I would like to add over here, since it's a virtual conference, and yeah, I am going to be a little bit strict with all of you, especially with respect to timing. So please stick to the timing of 12 minutes and 3 minutes of question and answer. And also, I would request all the participants, as well as all the invitees there, that please stick to the timeline as well of 3 minutes. One more point here I would like to add. Yeah, it would be, I think, convenient for all of us if you could post your questions in the chat, so that even after the discussion, you have plenty of opportunity to discuss your questions. Fair enough. Thank you. Thank you. And all the best to all the participants.
Yes, we have another chair of this session, also Dr. Chaya Jadhav. She is also available in the session. So look forward to your comments also, ma'am. You're not audible, ma'am, actually. Sorry. No worries, ma'am. You can just disconnect your one of the device, so automatically the sound issue is solved.
Yes, now audible?
Yeah, please.
Yes, ma'am.
Good evening, all of you. Myself, Dr. Chaya Jadhav from Pune. So welcome all the participants, and welcome, ma'am. And I should thank you for giving this opportunity. So already Saksham has given all the instruction. I request all the participants to stick to that instruction, so that we will complete all the presentation. Thank you, and over to you, Saksham.
Okay, ma'am.
Yes, Saksham. Look forward to Saksham first present.
Yeah. So now I would like to start with the papers. So first we have Rosette Luconch Savannah. And she's here with a paper on a wearable device for respiratory diseases monitoring in crowded spaces, case study of COVID-19. You may please start with your presentation.
Hello. Hey everyone, can you see my screen?
Hello, ma'am.
Okay, great. So my name is Rosette Luconch Savannah. I'm a master's student at the University of Rwanda in Internet of Things, and I'm here to present our work, what I've done with my colleagues, which is a wearable device for respiratory disease monitoring in crowded spaces, a case study of COVID-19. So let me put presentation mode. So why I chose this topic? Because there is no available effective tools to monitor the risk of spread of respiratory disease, especially in crowded spaces. And we have a contamination risk, which is there, and it's difficult to know the health status of surrounding people for self-protection. And also because we have so many diseases, which is now causing death in the world, and especially in Rwanda. So that is why I was motivated on this topic. And we can see that we have different diseases that can be transmitted from one person to another. And the detection of this kind of diseases are made by tests, which are time consuming, they are costly, and also the results are can delay sometimes. And in our context, we have so many non-communicable disorders such as hypertension and so on, which is difficult with this kind of diseases. And in our context in Africa, we have limitation in the resources, especially in energy and internet infrastructure, which is a big issue. So the objective of this study is to develop a smart wearable device to monitor the risk against respiratory diseases. And for that, we will investigate the state of art in respiratory disease monitoring systems and solutions. And we will find out the latest open source of IoT and machine learning techniques for wearable devices. Also, we will investigate available open data source for respiratory diseases, and to build and train, evaluate and optimize a model to do the automatic detection of those diseases. And lastly, it will be to design and develop a prototype for those respiratory disease detection. And like our hypothesis said that there is a existing open data source that can be used to train AI model to predict those diseases. And secondly, we have open source technologies that can be trained, that can be exploited to train AI model and optimize it for the monitoring of those diseases. And for the state of art, we try to look at the IoT integration of respiratory diseases, and we saw that little research focus on disease prevention, avoidance of those disease risk factors, and we saw that there is so many work that other researchers did in this topic, such as IoT. They use IoT to monitor the disease, and also machine learning to predict those diseases. And some other work focuses on TinyML and its application in respiratory health. But for all the papers we reviewed, we saw that the existing application of the respiratory disease, they focus mainly, they use the image and sound classification with the machine learning being done in cloud architecture. So this is a problem, as I mentioned before, in our context, we don't have so much internet infrastructure and also energy. So we are trying to implement those dynamic capability on the edge devices. So for the rest, I'm going to present how we did our wearable device. I will start by the methodology and then the machine learning process. After that, I will go with the system design, the edge architecture, the result we got, and the prototype results. So for our methodology, we use the prototyping method, which is an iterative method, and it involves the user and developer. As you can see, on each step, we need to approve in order to go to the next step, and finally develop the model and test it and maintain it. So for the machine learning process, we start by data acquisition, and we use two sets of data. One is a mobile data source we got on internet, and another one was collected on Agent Pass platform. And then after that, we do data processing, which involves the cleaning of data splitting. And then we design our model. And for this specific problem, it was a classification problem, we use the data neural network. And then we do the training. We try to experiment the number of people, advanced layers, and learning rates until we get the optimum training parameters. And then after that, we do the evaluation and the optimization of our model, and we evaluate it on the testing data. And after that, we convert it into a tiny machine learning model, which can be deployed on the edge device. So for our system, you can see here we have processing unit. We use the microphone to sense the sound, the infrared temperature sensor, and the ultrasonic sensor. For the processing unit, we use Arduino Nano VHDL. And for the user notification unit, we use an OLED display, the buzzer, and the plates. For the connectivity, we use a GSM module, which is a SIM800N module. And the architecture of our model, for the input, we have a raw data, which is the audio sound. And then we have the input layer, which contains the process features. And we have hardware layers. And the output layers, as I mentioned before, they are three classes. So we have COVID-19, cough, and noise. Here we can see the architecture of our model in Pass. Then the results we are obtained after training, we had an accuracy of 68.2%. And the on-device performance, we have the inference done on device in 1 second, which is good for the wearable devices. Then for our prototype, we tried to deploy our AI model on Arduino PF. And then the data were read from sensors, and the data we were reading were mainly distance, cough, sound, and temperature. And the difference result was shown on serial monitor and audio. And also the inference results were sent to the cloud for remote monitoring and future analysis. Here is the prototype we developed. oil components we use, and our system results we got from our prototype. Here it's the data we sent to the principal. In conclusion, I can say that our study proposed the use of edge-based AI technology to enable prediction of how safe environment is from respiratory diseases without the need for connectivity. And in our solution, we took sound, temperature, and proximity sensors to collect data from environment, and we use a dynamic model, and that dynamic was applied to predict if an environment is COVID-19 contaminated or not, if the user getting appropriate alert. And our model was trained using open data source, with the results showing that it's possible indeed to detect if a person in a crowded space is safe or not. So our solution will help to limit the spread of communicable respiratory diseases and public safety. And for the future work, we are planning to improve the model, especially the model accuracy, and collect more data for other diseases. This is all for me. Thank you for your attention, and the suggestions and questions are welcome. Thank you.
Thank you, Sarvana. Yes. Do you have any question?
So what is the efficiency up till now we have achieved?
Okay. I think the question is in chat. They are asking how I estimated the precision and accuracy.
Yes.
Okay. Okay, I can see the question. So as I mentioned, the stop sharing. Okay. So the estimation of the accuracy, I think I got it after training, and it was a automatic training using Agile Pass platform. And for the limitations, I got, it's about the sampling rate of my data. So the sampling rate was different because I got an open data set, and then I collected my own data for normal pop. So the sampling rate was a little bit challenging, and that is what affected the accuracy of my model. So it was not very accurate because of that challenge. Like as I mentioned, we are trying to work on that and improve it.
Hi, Savannah. Thank you for the nice presentation. I also have a question for you. I was wondering how exactly you identified your data set for the project which you did, and could you please throw some light on that?
Okay. So the data set for my project, I got it on Kaggle. It's an open source data set which contains sounds. Those sounds were recorded on COVID-19 patients during the COVID-19 pandemic. And on another side, I collected my own data because I wanted to classify three kind of sound. Well, the first one is COVID-19 related. The second one is just the normal cough, and the third one is the background noise. So that is how I did my data set for the project using example.
All right, thank you.
All right. So any more questions from the audience or the chairs?
Oh, thank you.
Okay, thank you for your presentation. Now I invite Rhino Arias with his paper on all vaccinated and open source web system for the control of vaccination process in health centers. You may start the presentation.
Hello, good afternoon to all. I start with the presentation. Can you see my screen?
Yes, go ahead.
Yes.
Yeah.
Okay. Greetings, dear audience. I am Rino Arias. I'm going to make the presentation of the work entitled All Vaccinated Open Source Web System for the Control of Vaccination Processes in Health Centers. This work was carried out by researchers from the State University of Quevedo and the University of Atacama, Chile. This presentation is structured as follows: introduction, needs and contributions, related words, proposed solution, discussion of results, conclusions, and future research. The introduction. Health professionals consider population immunization vital to prevent disease and health risks. To achieve this, an open source web system is necessary to control and register the vaccines received. While there is no defined development methodology for open source software projects, it is crucial to have one for the successful development of such a system. This research aims to develop a web system using an open source software development methodology called Scrum. Needs and contributions. Needs. Open source software projects currently lack a defined development methodology that provides guidelines to community participants for developing high functional and operational software. The contributions developing an open source web software that addresses health-related problems, particularly in the field of vaccination, following Scrum development methodology. About related words, a search of related words was carried out, and only Raman word presents a development methodology oriented to open source software projects called Scrum. But this methodology doesn't report software developed with this methodology. The proposed solution for open source web software focused on vaccination processes, the chosen development methodology is Scrum. It is a modification of the Agile Scrum methodology. It has 11 activities ranging from the search for volunteers to the repair of errors. The first step is discovery of problem and search for volunteers. Scrum enables us to propose a starting point for open source software development, which involved discovering the problem and finding volunteers for the solution. The first step was to create a blog where an individual or a small group could publish their idea and description, inviting contributors to join. The all paginated blob collected the names and email of people interested in collaborating. The next step was communication among development team members. With the mails obtained through the blob, an invitation was made to an initial communication meeting on Google Meet to discuss the needs of the health area regarding the systematization of vaccination processes. As a result of the meeting, the product features backlog was generated. This is posted on the blog. Initial launch planning meeting, the sprint of the product features backlog and its duration are planned, and then is shared with the main maintainers. Another meeting was held to plan the initial launch of the all vaccinated web system. Data collection techniques were used, and system development was planned. Release plan and status. The functionalities, the level of difficulty, and the percentage of progress of this are listed and reflected in the blob. Features update. Check if the community provided new features, functionality, or fixes for future approval by the main maintainer or main contributors. So far, the product feature backlog has not been modified in this project. Source code testing. The source code for all vaccinated is hosted on GitHub, and a test version of the system is available to the community. Bug reporting. A template was provided to the community so that they can report software bugs, collect, and later publish them on the blog. The bugs have been published, for example, one, insecure login, two, error in the vaccinate patching functionality, three, error when modifying vaccine information, among others. Community collaborations. Extended contributors can join to the project and can add new features, fix bugs, or contribute significantly to the development of the project with the approval of the main maintainer. In this case, no new developer or contributor has joined the project. Bug fixing. Reported bugs or errors were corrected by the contributors and uploaded shortcomings to the repository where the project is hosted. Approval or validation. The solution proposed by the community to the bugs are listed by the main maintainer, who reviews, validates, and finally approves them to improve the system and prevent the software from having bugs. The final step is process iteration. The steps are repeated as many times as necessary to complete the system functionalities and new ones and maintain them. About discussion of results, the all vaccinated software was designed to optimize vaccination processes in health centers and care for the largest number of patients in the shortest possible time, allowing proper management of information on vaccines, patients, and users. The Oscroon development methodology has facilitated project planning and has allowed the generation of quality software. However, there is a limitation in the formation of development methodologies from open source software projects. Finally, conclusions and future research. This study sought to develop an open source web software using the Oscrew methodology to facilitate the implementation of a free vaccination process control system for health centers. The Scrum methodology, being an agile methodology, allows easy planning and incorporation of new functionalities. The open source software project, although it allows for the informed planning, has been successfully developed thanks to the Scrum methodology. Since it has established a work standard so that collaborators can continuously and autonomously and individual contribute to the project. As future work, it is proposed to evaluate the system with the users and improve it based on the results obtained to satisfy their specific requirements and needs. Thank you for the time. Any questions?
Thank you for the presentation, Reno. I have a question. Sorry, I missed that particular point. It seems maybe you have explained it. I'm sorry for that. I just wanted to know the difference between Scrum and Scrum methodology.
Okay. The main difference is about the planning. For the traditional projects, I can identify the Scrum Master, the product owner, and the development team members. Okay, but in Scrum methodology, not exists these people because Scrum is oriented to open source software projects. Okay, entonces on the open source software projects, not has a Scrum Master or not has a product owner because is the community, is the open source software community, which is continuously contributing from code and basing on idea, and is the most important difference.
All right, thank you. One more question, if you could answer me. I was just wondering how you have implemented the security part in Scrum. Because I just identified you have different levels. So maybe if you could throw some light on that.
Okay. The security part on the Scrum has not defined it, but when release when make the product backlog features, that is this must a requirement. The security part must a future of the backlog of
Okay.
Okay.
Yeah, no problem. Thank you.
Thank you.
Okay, thank you.
Any more questions?
No. Already he has answered.
Okay. So thank
Thank
you
you.
for your presentation. Now I invite Iriana Kornikova to present a paper on computing technologies in the development of quantitative criteria for calculating the required dose of insulin in patients with type 2 diabetes. You may start your paper now.
Yeah, Irina, you are here. I think so. Saksham just she left the session. I think so due to some technical. So we can wait for next 30 seconds. Yes, she is connecting.
Okay.
Yes, Kharnikua, you are there. No, you are not audible. You can do one thing. You can just disconnect this session and rejoin the same. We can go ahead with the next presentation, and after that we can call you again. That Saksham, we can skip this presentation and announce the next presentation. After that, we can call to the Irina again.
Okay. So I would like to invite Haruki Asano. Yeah. His paper is on multitasking learning method using emoji predictions as auxiliary task for sentiment analysis. You may start your presentation.
Okay. Can you see my screen?
Yes,
Oh.
visible.
Oh, okay. Let me start my presentation. Hello, everyone. My name is Haruki Asano. I talk about multitask learning method using emoji prediction as auxiliary task for sentiment analysis. Sentiment analysis is a process of mechanically recognizing sentiment from text. Sentiment analysis includes methods targeting negative, positive, and various sentiments such as joy, anger, and sadness. In general, analysis of various sentiments is more difficult than analysis of negative and positive. One reason is the very high cost of annotation. Sentiment analysis has been researched in Japan. MLRask is the emotional word dictionary-based pattern matching method. It is frequently used to analyze various sentiments in Japan, but dictionary-based methods are less accurate because it is difficult to recognize context. In recent years, analysis of emotional state and the spread of COVID-19 has been researched in Japan. Most of the sentiment analysis targeting various sentiments is applied research, whose works aim to improve analysis accuracy of various sentiments in Japan. In recent years, there are works on sentiment analysis using emojis. Emojis are graphic symbols that represent sentiment. There is distance supervision using emojis. This method automatically generates teacher data based on the relationship between emojis and sentiment. The below figure is an example. This smiley emoji is supposed to represent joy. In that case, right teacher data can be generated from the left text with smiley emoji. The advantage of this method is the low cost generation of teacher data. However, generated data contains noise because ideal data always cannot be extracted. This work's motivations are data augmentation in sentiment analysis and improvement of the accuracy of sentiment analysis targeting various sentiment. We propose multitask learning method using emoji prediction as auxiliary task for sentiment analysis. Our method transfers only useful knowledge from emoji prediction to sentiment prediction. This method makes it possible to reduce the effect of noise on data generated from emojis. Distance supervision is performed following the conventional method. Texts are collected from Twitter using Twitter API. In our method, emojis are embedded in 8 sentiment values using emotag 1200. Emotag 1200 is annotated with associations between 150 emojis and 8 sentiments by 9 letters. This dataset shows the objective relationship between emojis and various sentiments. Therefore, we then define the task of predicting the values of emotype 1200 from the text as emoji predictions. This figure is the architecture of our models. Our model uses multitask learning. Multitask learning is a method of running multiple tasks with a single model. Our model jointly runs emoji and sentiment predictions by deep learning-based multitask learning. In general, multitask learning models with only a shared encoder. On the other hand, our model is a shared private model with a task-specific encoder. This model is able to appropriately train multiple datasets in different domains. We use this model because emoji and sentiment prediction datasets are expected to be in different domains. In our work, we perform two types of experiments. One is an experiment with datasets targeting various sentiments, and the other is an experiment with datasets in different domains. The former experiment compares the performance of the model with multitask learning and model learning of sentiment prediction. The latter validates the effectiveness of the proposed method in case the domains of emojis and sentiment prediction are different. In this experiment, there are two types of emoji prediction dataset. EPD8 is created by sampling 8 types of emojis. EPD5 is created by sampling 5 types of emojis. We select the emoji with the highest value in each sentiment of emotype 1200. In both cases, we sample 4,000 each of the text with the target emojis. Sentiment analysis datasets are rhyme and Japanese realistic texture entertainment corpus. Rhyme is annotated with 8 types of sentiment labels and created from SNS text. Japanese realistic texture entertainment corpus is annotated with 3 types of sentiment and created from hotel review text. Emoji prediction dataset is created from Twitter. Therefore, the domains of rhyme and emoji prediction dataset are similar. On the other hand, the domains of Japanese realistic texture entertainment corpus and emoji prediction dataset are not similar. So Japanese realistic texture entertainment corpus is treated as dataset in a different domain from emoji prediction dataset. These are comparison models in the rhyme experiment. BAT is used for all encoders. BAT base is a trained model on only rhyme. BAT AUZ is a trained model on rhyme and EPT8 combined dataset. The sentiment categories of EPT8 and rhyme are the same. Therefore, they can be combined. This model is equally trained on rhyme and EPT8. But MTL is a trained model by multitask learning with only a shared encoder. But SPMTL is a trained model by multitask learning with task-specific encoder. And this model is our model. P at K, L at K, and F at K are used as the evaluation index. These are precision, recall, and F values for the top K cases. This is the result for rhyme. F at K of BAT AUZ is decreased compared to BAT base. This result suggests the possibility of inappropriate level weight between rhyme and emoji prediction dataset, and overfitting to noise in the emoji prediction dataset. On the other hand, F at K of BAT MTL and BAT SP MTL is improved compared to BAT base. This result suggests that the knowledge representation obtained from emoji prediction contribute to sentiment analysis by reducing the effect of noise. These are comparison models in the Japanese realistic texture entertainment corpus experiment, but is useful for encoders. The structure of BAT base, BAT MTL, and BAT SPMTL are the same as those used in the RHYME experiment, but Japanese realistic texture entertainment corpus and EPT5 are used for DZ. So precision, recall, and F value is used as the evaluation index. This is the result for Japanese realistic texture entertainment corpus. The F value of BAT MTL and BAT SPMTL is improved compared to BAT base. This result suggests that multitask running is effective in the analysis of negative and positive. BAT base, BAT SPMTL is slightly more accurate than BAT MTL. This result suggests that the task-specific encoder is effective in case the domains of emoji and sentiment prediction are different. Sentiment analysis targeting various sentiment is very high cost of annotation. There is distance division using emojis. The advantage of this method is the low cost generation of teacher data. We proposed multitask running method using emoji prediction as auxiliary task for sentiment analysis. Our method makes it possible to reduce the effect of noise on data generated from emojis. Also, the task-specific encoder is effective in case the domains of emojis and sentiment prediction are different. In the future, we are planning to change the encoder and the emoji sample method. The encoder currently used is not suitable for the analysis domain. Therefore, we plan to use encoder pre-trained on SNS text. Also, currently, text with emojis is extracted at random. So a rule-based filtering will be used to extract text with emojis. That's all. Thank you for your attention.
Yeah, I think so. Jonathan Roscoe has some query, I think.
Hi, yes, so interesting work. I've done some work on disinformation, and we use sentiment analysis, which we found in that domain highly unpredictable because people are happy and sad about things that other people are sad and happy about. I'm just wondering, have you thought about the different ways that emojis are used, perhaps in a non-intuitive way? The obvious example being ones like peach and aubergine emojis. You know, the emojis do not have necessarily a universal meaning, particularly in other languages or within certain groups and people who are using them.
Oh, sorry, I could not catch your question. Sorry.
Sometimes emojis have a double meaning.
Oh, okay.
Is that something you've considered?
Sorry, sorry, I can't answer your question.
That's okay.
Oh, sorry.
Can you please write the question into the chat to the so that
yes, yeah, of course.
Yeah. Till that time, is there any other question from the chair or any audience?
Haruki, I have a question.
Okay.
It's a very interesting subject actually, and I was wondering, along with the question just now, one of the participants or colleague asked for. I was wondering whether sample size really affects the emoji prediction.
Yes. So in this experiment, where we add samples to sorry. In this experiment, we I extracted to be roughly the same size as the rhyme. And so this M's prediction dataset is optimized for rhyme. So I change to sample size to M's prediction dataset sample size to as I will try it emoji. I will try change sample size emoji prediction dataset emoji prediction dataset of sample size.
All right, so it seems you have not actually worked on different samples, because right now the slide which is being open in front of me, where I can see 32,000 samples and yeah, 20,000 samples. So is it really affecting the precision value or something else, evaluation parameters? I'm not sure.
Evaluation. Sorry, I could not get your question.
No problem,
Haruki.
Haruki. Maybe you can just see the chat question and
chat questions.
yeah,
Sorry.
and try to answer.
The chat, the Jonathan have a one suggestion for you, so you can just take the link for your further. Yes. Thank you, Haruki, for the.
Sorry. Thank you.
Yeah.
Thank you.
Yes. Dr. Jadhav, you have a question, any?
No, thank you.
Thank you.
Thank you.
Irina is again joined the same, so look forward to the.
Yeah,
Hello, can you hear me now?
yeah, now you're audible.
Good. Sorry for earlier.
Yeah, problem.
Okay, so give me a moment.
Okay.
Can you see my screen?
Yeah.
Okay. So today I would like to discuss computer technologies in the development of quantitative criteria for calculating the required dose of insulin in patients with type 2 diabetes. So treatment of diabetes is determined by the type of disease, and the level of compensation includes several options: oral hypoglycemic agents, insulin, or combination of both. However, when the question concerns switching the patient to insulin therapy, general practitioners do have some questions which have not been resolved historically, especially when you consider that at least 30% of patients with diagnosed type 2 diabetes receive insulin therapy. The questions are related to switching to insulin therapy, identifying involved risk factors for the formation of insulin requirement, monitoring patients receiving insulin therapy, and increasing the requirements for insulin dose. Why that happens, its causes, probable risk factors, and what changes could be required. All these questions formed the basis for our study. So we distinguish between primary and secondary insulin resistance. Secondary insulin resistance can be defined by not elevated endogenous insulin levels, and the dose of insulin received is higher than the physiological need of a person. Secondary insulin resistance causes today are mostly assumed, as insulin is a foreign protein that antibodies can be produced to. But in this test, we did not study these antibodies, since we have been looking for a correlation between level of anti-insulin antibodies and insulin resistance for a very long time. But in all the studies that have been done, there was no reliable connection established. So our study included 294 patients with type 2 diabetes, including 213 who received insulin therapy. All patients gave the informed consent to participate in the study. So the patients were divided into 3 groups: 2 observation groups and 1 comparison group. First observation group with 104 people were patients with type 2 diabetes receiving insulin therapy within the standard physiological requirement, so up to 40 international units per day. Our second observation group with 109 people were patients with type 2 diabetes receiving insulin therapy more than 40 international units per day with secondary insulin resistance. And the third comparison group with 81 people were patients with type 2 diabetes receiving only oral hypoglycemic drugs. So research methods were just basic history and physical examination, blood testing, then insulin and C-peptide were determined by immunohemoluminescence, and we also determined immuno-C-peptide ratio for assessing insulin. Primary insulin resistance was determined by the HOMA index, and secondary insulin resistance was determined by the dose of insulin consumed. The groups were fully comparable in terms of biological gender, their age, and their body mass index, with no significant differences were found in any of those criteria. Close to significant differences between patients in the observation and comparison groups were identified in terms of the duration of observation of patients and the duration of insulin intake within the observation group. However, these were quite understandable and expected differences because the high interest of patient in studying in our School of Diabetic Patient, which was established on our clinical base where our study was conducted. So this observation group had the high interest because it is associated with insulin therapy they were receiving. In observation group 1, on average, the dose of insulin received was within the physiological requirement and amounted to 26.2 international units per day. For patient in observation group 2, the daily dose of insulin was much higher and was in range of 73.7 international units per day. When we studied the relationship of secondary insulin resistance with anthropometric parameters, the level of comorbidity and the preservation of functional reserves, it turned out that the dependence of the dose of administered insulin has a pronounced dependence on the comorbidity index and can even be described by the formula. Prescribing insulin to patients with type 9 diabetes is a sufficient problem even for endocrinologists, since there are no objective criteria for calculating the starting dose of insulin, and as a rule, the dose is selected empirically, just based on the subjective assessment of a particular specialist. For example, by selection method in hospital, where doctor just prescribes some starting doses, and during the day they monitor level of sugar and the physiological response of the patient. In an outpatient setting, this is impossible because it involves a huge risk to the well-being of patient. The development of quantitative criteria for calculating the required dose of insulin for patients with type 2 diabetes mellitus during the initial appointment of insulin therapy against the background of an established insulin need can significantly improve the quality of care for patients with diabetes. So our invention allows to quickly determine the required dose of insulin in type 2 diabetes mellitus, which is relevant to solving this problem. So the required estimated dose of insulin was assessed by the quality of diabetes compensation in terms of glycemia and glycated hemoglobin. And the calculated value of the insulin dose is sufficient for adequate control of blood glucose levels, as glycemia indicators are within the target values for the particular patient. A patent for this invention, which is called Methods for Determining and Calculating the Required Insulin Dose in Type 2 Diabetes Mellitus and Established Insulin Dependence, was obtained on August 31st in 2018. Also, based on the results of our studies, recommendations were developed on the tactics of managing patients with secondary insulin resistance, and the next in other patent was also received. So in patients in observation group 1 with preserved production of their own insulin, there was no clear dependence of the insulin dose received on the duration of the disease and on the body mass index, but the relationship with the age of patient was confirmed. Age-related insulin resistance is a well-known phenomenon and was confirmed by qualitative studies by Peters and his team as early as 1989. But in patients who needed a dose higher than the physiological need to compensate for carbohydrate metabolism, as in observation group 2, the value of this dose depended on both the duration of the disease and body mass index. Duration of type 2 diabetes for more than 10 years can be attributed to a number of significant risk factors from the features of the clinical course of the disease, although the risk of insulin requirement formation begins to grow as early as 5 years after the manifestation, and among other things, this indicates that we do not currently have sufficiently effective methods for the treatment of primary insulin resistance. And regardless of the duration of the disease, the level of comorbidity above 14 points according to SIRS increases the chances of prescribing insulin therapy by 1.46, almost 1.5 times. But the body mass index, contrary to our expectations, did not have a statistically significant effect on the increased risk of insulin requirement. On the contrary, it manifested itself as a protective factor. Of course, in fact, it is not, and we will not treat it as such, but indirectly confirming the high level of primary insulin resistance, it can serve as marker of functional safety of beta cells. For the formation of secondary insulin resistance, the same criteria turned out to be significant factors for the formation of insulin requirements. The most significant complications for the formation of insulin demand are microangiopathy, retinopathy, and nephropathy, and diabetic autonomic neuropathy. The relative risk increased by more than 2 times in the presence of retinopathy and nephropathy, and by 1/3 in the presence of diabetic autonomic neuropathy. The risk of formation of insulin requirements, depending on the structure, was significantly higher in patients with diseases in the gastrointestinal tract, and with chronic heart failure. But the presence of other endocrine diseases had a protective effect on the risk of insulin requirements. Least of all, patients receiving insulin was in the group of patients with chronic inflammatory diseases of the urinary system. So to conclude, the problem that prescribing insulin to patients with type 2 diabetes, it's a problem even for experienced endocrinologists, since there are no objective criteria for calculating the starting dose of insulin, and as a rule, the dose is selected empirically based on the subjective assessment of a particular specialist. For example, by the selection method, in a hospital with permanent observation, where doctors prescribe doses, and during the day they monitor the level of sugar. In outpatient setting, this is a big risk and almost impossible to do. The development of quantitative criteria for calculating the required dose of insulin for patients with type 2 diabetes mellitus during the initial appointment of insulin therapy against the background of an established insulin need can significantly improve the quality of care for patients with diabetes. Thank you for your attention.
Thank you for the nice presentation. There is a question. Have
Yes.
you considered age factor, age-wise patients have you considered?
We were performing our test on patients of pretty young age, from 18 to 30.
So what is the conclusion in that on the early age or like that?
So we selected to work with younger patients because we were able to, well, first the aim was to make their life quality much better, to assess their problems much quicker and find a solution for them as quick as possible. So we chose this demographics, and we were able to monitor them for a very long time to see that this method is working.
Okay. Thank you.
Okay, Irina, another chair, do you have any question?
No, thank you.
Thank you so much.
Thank you. Saksham, look forward to the next presentation.
Okay. Thank you for your presentation. Now I invite Jonathan Roscoe with a paper on security of input for authentication in extended reality environments. You may start your presentation now.
Great, thank you very much. Can you see my screen?
Yes, yes.
Yeah.
Visible.
Lovely, thank you very much. So I'm here to present this work by myself and my co-authors Tiago Andrade and Max Smith-Creasy. It's part of a series of concepts we've been developing to explore the security of extended reality environments. Extended reality covers a family of technologies, including virtual and augmented reality. And we see their potential for use in professional contexts, including areas where security is a paramount concern. In this concept paper, we explore a technique to help prevent the XR equivalent of shoulder surfing, preventing people from eavesdropping, spying on what you're doing in a virtual environment. So extended reality technology really promises to improve how we communicate, learn, and share knowledge in a variety of environments. VR still hasn't quite reached the tipping point of becoming mainstream yet. Headsets are bulky and expensive. Software platforms are complex. But we still see the potential and are laying the groundwork for future use cases. For example, we've got a virtual reality security operations center that provides a secure environment where remote workers can collaborate as they would in a traditional operations center. They can take advantage of new forms of visualization and really immerse themselves in the data, gaining new perspectives. We're also using it to train our employees, so we're giving them exposure to technology prior to working in the real world, or by gamifying things like physical security behaviors. The point is that although the technology is most used for games at the minute, we see a day where it will be commonplace office technology in one form or another. We have some previous work on this. A couple of years ago, we looked at how shoulder surfing might work in VR. Can you tell what someone is inputting to a virtual environment based on the way they move? Not only that, but sensors track every movement, meaning that if that data is intercepted, it could potentially be reconstructed to identify exactly what a user was doing. So we experimented with this using 3 games and demonstrated how they were distinctly recognizable based on the interactions. And what you can see in these 3 games are different ways of behaving and moving. So in the top one, for example, we have a number of different events, such as the user wandering around a room, picking up a bottle, smashing a bottle. In the second one, it's a constant rhythm video game, and you have many sequences of blocks that have to be rapidly hit. So there's lots of movements there. And in the third one as well, you have lots of movement again, but a different kind of movement, as well as different kinds of key events where users striking out with their hand. And what we were able to see is that from the accelerometer measurements, we could distinctly recognize and classify with dynamic time warping what game a user was playing, what activity they were involved in. So in conclusion, we feel that user movement through accelerometers is a possible side channel for identifying activity of users in XR. So the question is, how can we overcome this XR shoulder surfing? Traditionally, if someone's walking around an office looking for passwords as people type them in, we can see that. We can take measures to prevent that. But in XR, it's very difficult to be very fully aware of your surroundings, and movements may be exaggerated. Not only that, but there's other devices, things like health trackers, Fitbits, watches, that constantly measure and track your movements. If that could be mapped to what you're doing in an application, potentially your input could be eavesdropped. So our proposed solution is to create user interfaces that introduce subtle changes. So this means that when inputting sensitive information, users are not making repetitive actions. We've actually since learned that this has been implemented before historically in other places, such as this keypad in the image you can see that randomizes number positions. So every time you enter your PIN code, your numbers are in a different position. You're not making the same motions, which we know is a very easy way to eavesdrop. In VR, we can change positions not just on a 2-dimensional keypad, but in 3D space. We can also do things like change the size and color and other appearance of interactive elements. The result is that for the same task, a user must do different things. It may be as simple as distracting the user, forcing them to pause before they're proceeding, but it could be something more complex. So for an outside viewer, it's a lot harder to determine what it is that they're doing. So we established an experiment to determine how this might be achieved and to what extent we needed to do this. Our initial experiment is based on an alphabetic PIN-based authentication system. So we created a simple PIN entry system that had an 8-key alphabet keyboard. And we created 3 versions of this keyboard. We had the original one, which is a simple layout you can see at the top, which is 8 buttons. And from those 8 buttons, we had to enter a 5-letter combination. In this case, it was the word pilot, as this was a pilot project. We also created an adjusted one. So in this one, the button position remained the same, but their values changed, moved around that 8-key layout. And we created a fully randomized one where the size and location of the buttons would change in 3D space, moving around entirely, being different sizes at different distances away from the user. So they really had to move their head around so they could see everything and interact with things. We collected 400 samples from these keyboards, including a control sample. To measure the impact they had, we recorded the angular acceleration of the input device. In this case, it was an Oculus controller, which is a handheld device, which takes various measurements and has a number of buttons on it. In the first figure on the left, you can see the distribution of mean angular acceleration across the different layouts. Whilst the original and control layouts are fairly tightly clustered, the adjusted and randomized layouts are spread out. In the second figure, you can see these grouped by the user. One user in particular had tight clustering over all layouts. This may be due to the experience of the user who had greater familiarity with VR. But the key result is that range of movement that range of detectable movement is significantly greater for the changed layouts. So whilst we had the original and the control studies, we weren't moving much. People's hands were only making small movements, but with the others, they had to think, they had to move around, and that range of motion increased drastically. So our results show that randomization causes the user to pause, look, and think. But really, we want to avoid this being an inconvenience. It's difficult if your user interface changes all the time. There are other things as well, such as in our experiment, we only looked at a narrow 120-degree field of view, yet in VR, we have a full sphere around the user to play with. And also, eavesdroppers may use cameras. They may use accelerometers from XR devices themselves, or as I mentioned, other common devices such as fitness trackers. So there's a lot more we can do to help randomize the movement of the users. However, there's a trade-off with usability. So further research is required to understand the existing difficulty of eavesdropping and also the level of tolerance that users have for adjustment. We don't want to make them uncomfortable and struggle to work with the interface. So really what we wanted to have is a call to action for further exploration of this research. So to conclude, extended reality promises to change how we work in the future. However, we need to be aware of the new security landscape that these devices and specifically how we interact with them present. We need to review UI design for extended reality environments as they continue to develop and be aware of how they may be abused. Further research is required to understand the threat landscape and the mitigations that can be taken, but we hope that this early work is the start of a larger body of research into the problem area. So thank you for your time, and are there any questions?
Thanks, Jonathan, for the interesting presentation. I also worked something like this during my research. So I have a couple of questions, if you may answer. And yeah.
Yeah.
All right. So, my first question is: can I say this type of attack is shoulder surfing attack?
In some cases, we do see it being done that way. So it may not be the best term for it, I think, but it's probably the greatest analog we have to existing attacks with traditional technology. Now, it could be done in a number of different ways. There could be different levels of knowledge. So, for example, if someone uses a glyph as a pin, for example, you may know that, I don't know, to access a system, they draw a triangle in the air, but without seeing them do it, you don't necessarily know exactly what way round that triangle might be, or whereabouts, its height, that sort of thing. So we do expect there's an angle of visual observation with VR eavesdropping. So shoulder surfing feels like a good analogy.
All right, thank you. Another question I have, because it seems to a very interesting presentation to me. You were talking about something related to angular acceleration and randomization. So I was wondering, did we consider the angle of that and maybe any threshold value?
Yes, so definitely. If I go back in my slides to this one, so we can see with the original and controls, for example, the kind of maximum range is up here with the original. So what we think is that anything within this space, this magnitude of acceleration, is where there's a high level of predictability and ability to reconstruct the input. And we've seen that ability to reconstruct input in our prior research. But we think by extending that range, so going into where the red and the green are with the randomized and the adjusted layouts, that's how we prevent that ability to reconstruct the input and prevent that eavesdropping.
All right, so here I can see the threshold range is 1.6, if I'm right.
That was the maximum that we observed based on the user's interactions in this scenario, but it could be greater.
All right, wonderful. Thank you. Thank you so much.
Okay, well, thank you very much for your time.
Thank you, Jonathan.
Yep.
Dr. Jadhav, you have any question?
No, thank you.
Okay. Yes, Aksham, look.
Okay. Thank you for your presentation. Now, moving on to our last presentation, I invite Maria E. Sabani with a presentation on BB84 quantum key distribution protocol and potential risk. You may start your presentation.
Hello to everyone. I'm Maria Sabani and I'm from Greece. Can you see my screen?
Yes, yes.
Yes.
Okay. We are from Department of Digital Systems of University of Thessaly, and we have made a paper about the quantum key distribution protocol, the BB84, and its potential risks. We will discuss about quantum computing, cryptography, quantum cryptography, quantum key distribution, the BB84 protocol, its security, and we will have some conclusion. We have to say that the quantum computing is the hotspots of quantum physics, mathematics, and computing. It's a subject of main interest in that study nowadays, and uses the property of quantum mechanics to the processing and construction of computing system. It's a bit fascinating because while in a classical computer, we have the bit, the binary digit that takes value 0 or 1. In a quantum computer, we have the qubit that can be in basic states, get 0 or get 1, or in a state which is a linear combination of the two states. And this mathematical expression claims the quantum superposition. I don't know if you know about the Schrodinger's cat. This is quantum superposition. Geometrically, a qubit can be represented by a sphere, and this is a block sphere named by the Swiss mathematician Felix Bloch, and is in a three-dimensional Hilbert space of the state of a quantum system of two-level or qubits. We have some fundamental principles in quantum computing, that is quantum superposition, quantum entanglement, and quantum supremacy. Let's see some details about them. Quantum superposition is what we have discussed before, that if we want to measure the state of a qubit, we can take both values 0 and 1 in the same time. And we take the value get 0 with possibility A on the square, and value get 1 with possibility B to square, such that together we have the sum of the unit 1. A qubit in a quantum computer can be stored or be in two states simultaneously, and this is quantum superposition. Magical that. We have the quantum supremacy because of these principles and laws of quantum physics. The quantity of information that can be stored in a quantum computer is huge. So quantum supremacy is a term and is a property, of quantum computers, and is a proof that a quantum computer can solve any problem that a classical computer cannot in a specific amount of time. Quantum entanglement is the phenomenon that two particles interact each other irrespective of the space or the obstacles between them. And if we have one particle in one point of universe and the other in the other point of the universe, if we can measure or we can know the state of the one particle, then we can know the state of the other instantly. While the qubits are in contact, the information travels at lightning speed, and this was known by Einstein's phrase that is a spooky action at distance. So cryptography is the science of secure communication that applies complex mathematics to the design of powerful cryptographic methods. It's very important in daily life because we use it every day in transaction, communications. If we want to send an email, we use cryptographic SIMs. So the cryptographic SIM must have some principles: confidentiality, integrity, and authenticity. A crypto system is based on three things: plain messages, pure messages, cipher messages, and the keys. The crypto systems are both symmetric and asymmetric, and this how do I say? And the type of key they use is this distinction to symmetric and or asymmetric. Quantum computers will have powerful capabilities that solve a wide range of problems and are capable of generating new threats at unprecedented speeds and scale in modern cryptographic protocols like RSA. So in 1994, the American mathematician and cryptographer Peter Shor presented an algorithm that changed things up and proved that with quantum computers, the period of a periodic function can be found easily and quickly, and therefore the prime factors of large prime number. So quantum computers overcomes difficult mathematical problems like the integer factorization, which is based RSA, based on integer factorization, and the discrete logarithm problem, on which is based the security of modern crypto systems. The first concepts about quantum cryptography is in early 70s, while Stefan Wisner tried to publish his paper about quantum money, and ASGERM appeared in 1984. It is the science that applies the principles of quantum mechanics in order to securely transfer or store the data. The fundamental laws of nature and physics make quantum cryptography the only approach which ensure secure communication between two parties. A quantum computer can support and help to the development of a new and faster and stronger cryptographic protocol. And in quantum cryptography are being applied classical cryptographic methods, but these are extended and improved with the help of quantum mechanics. Quantum cryptography use a classical approach of a crypto system, such as one-time pad, to transfer a message, but the quantum key distribution is the fundamental in quantum cryptography because it used to create a private key and encode or decode the message. So quantum key distribution exploits the principles of quantum mechanics to generate a key through a quantum channel. And because of the randomness of the quantum states and their measurement, we have a randomness in the creation of the key. Excuse me about the noises. Quantum key distribution exploits the non-cloning theorem. So we have a unique key, and the uncertainty principle of Heisenberg while we have eavesdroppers in this whole attempt, excuse me, an eavesdropper is revealed when attempts to break this procedure. So in quantum key distribution, we have two channels. We have the public channel and the quantum channel, and assume that we have two parties, that A and B, that are persons or devices that want to communicate. So in the public channel, we have the communication, the messages, and in the quantum channel, which is an optical fiber or something like that, we have the processes of generating the quantum key. Due to the uncertainty principle, this measurement can detect any intrusion in the quantum key distribution transmission and reveal an eavesdropper. An eavesdropper, in the effort to read the photons, will change the state of them, and this change will reveal the information that has been elicited. So in 1984, these two guys, Charles Bennett and Gilles Brassard, made a protocol, a quantum key distribution protocol, the BB84, named by their names and surnames and the year that has been published, and consists of two channels: a quantum channel that takes part the quantum communication, the quantum transmission, excuse me, and the classical channel that takes part the communication. We use two polarization bases, the rectilinear and the diagonal bases, and with this table, we can see how a bit can be encoded. Let's see the phases. So we have Alice, part 1, that wants to encode her bit 0 or 1, and chooses a bit string and a random combination of bases. Encodes her bit string with the aid of the bases she has chosen into polarized photons and sends her photons to Bob, part 2, part B. Bob receives Alice's photon and chooses a basis to measure each one of them and gets classical bit. So Bob obtains a bit string, and this pair is called the row key pair. Then we have the shifting step of the protocol that Bob announces into the public channel the basis he used. Alice, she has chosen some basis and selects the cases that their choices match. So the two parties discard all the bits which the encoding and the measurement are different. Well, I don't want to be very boring. So I will give you an example. Let's see. Alice chooses the bits 0, 1, 1, and her basis. Sends the photons that have been polarized with this basis, and then Bob choose some basis also. So you can see that the shifted key is when these bits and bases matches. Quantum key distribution protocol proved to be secure against certain attacks, and here have been proposed several proofs of the security of the protocol. The quantum systems flaws, the natural limitation in the detectors of the single photon, and the optical-electrical imperfection are some of the reasons that question the security of the quantum key distribution protocol. So we have some attacks. Some typical attacks, and that we will discuss about it, is the intercept and resend attack and the Trojan horse attack. That is the same in the classical computers. The intercept and resend attack, if an eavesdropper intercepts the signal, the light photons that sends Alice and measure each of them. If, according to the measurement result, will prepare and send new signals to Bob through a noising channel. And if, since the environment is ideal and the detectors are efficient, it can guess the photons that Alice sends, and she replace them and send them as hers, as per his polarization basis. Bob will receive the photons with the same rate.
Sorry,
Here-
Maria. Sorry,
Ex-
Maria, for
yes.
the interruption. The time
Yes.
is going to be up for you.
Yes, and for this, I will go to the Trojan horse attack that it's called and light injection attack, and I will say that if put light in the quantum channel and with the reflection can change the state of the polarized or the modulator. The laws of quantum physics establishes a secret key generation and exchange between two or more parties with ensured security, but we have some loopholes because of the unwell constructed detectors and something like that. And for the future research, we focus on modifications that can be made in these devices of quantum systems, and some other aspect and challenges is the distance between the patterns that execute the quantum key distribution. Thank you, and I'm sorry about all this interruption.
Thank you, Maria. Thank you. So, Chair, any question?
No problem, Maria. I have a question. First of all, thank you for such a nice presentation.
Thank you very much.
Nice
I was just wondering on the point, no cloning theorem, where you were talking about unique
Yes.
key. So could you
What
please
is the
elaborate?
non-cloning? You want
Yeah.
me to say what is the non-cloning theorem?
And how it actually reflects to
Oh.
unique key?
Okay, well, the non-cloning theorem is an evolution of the no-go theorem that claims that in two quantum states, we can have a fake one. We can replace or substitute some quantum state with another. It's due to the quantum principles, the principles of quantum physics, that a quantum state is unique. And in cryptography, we want to have a unique key, and that cannot be made a same. We can make a same one. We can make a fake one.
All right, so that means in cryptography, we are talking about symmetry key, where we are going to use one key, private key, right?
Yes, yes.
Is it going to be same as the unique key?
No, nowadays in cryptography and in quantum cryptography, we use asymmetric keys, asymmetric crypto system that use different type of keys, so in symmetric crypto system is not in use.
Okay, thank you.
You're welcome.
Thank you.
Okay, so other chat don't have any questions. So audience, do you have any question? Fine. So audience don't have. Thank you, Maria, for the wonderful presentation.
You're welcome.
Section
Thank you.
closing remark.
So I sincerely thank all the authors for their excellent participation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. On the behalf of the whole team, thank you for your support during the 8th version and the previous 7th version of the conference, and we'll be happy to have you in the 9th version of the conference in 2024. All the presenters would be getting their digital certificates in 2 or 3 working days. Further, all the papers are being forwarded to the Springer. The publications will be live in 6 months. Kindly cooperate with the team of ICICT 2023. We also thank you, session chairs, Dr. Chaya Jadhav and Dr. Deepti K. Sharma for chairing the session. A token of appreciation, the chair on the behalf of Team ICICT 2023 and Global Knowledge Research Foundation and the partners. Thank you for your valuable presence.
Thank you so
Now,
much.
Thank you,
kindly,
Saksham.
please.
Thank you, Chaya ma'am. Thank you, Dipti ma'am. Do you have any session remark?
No, nothing, but just one thing I wanted to add. It's a really a pleasure being all of you today. Thank you so much. And really, we observed active presentation and discussions. And I hope everybody enjoyed the presentation and they are going to use it for their future project or maybe the current project. Yeah, I also would like to thank moderators, my co-session chair and organizers. Um, um, yeah, and all the audience for joining and sharing the session. So thank you so much.
Thank you.
Thank you.
Same thing here. Thank you. And all the topics were very interesting topics. And all the best for the authors for their future and organizing team. It's always been with.
Thank you. Thank you so much, ma'am. I request you all the authors to turn on the camera for the quick snap for the next 10 seconds. Yes, please.
I'm afraid I no longer have my camera working.
Yeah.
Yes, done. Thank you. Thank you so much to all the presenters. Thanks a lot, ma'am.